So, good evening, everybody. This is the Zoom lecture, Thursday, April 9th, Heavy Civil. Hopefully you have the PowerPoint. Actually, it's a PDF for you of the second estimating handout. And this was a building that one of the first I worked on up in Maine, up in Limestone, Maine, near Caribou. Interesting, they were on the news the other day. I guess they're using dog sleds to get medications to everybody. That's how much snow they still have. So, although about an hour ago it was snowing here, so we got that going for us, which is nice. This building that we saw earlier is very similar to this one. This one was a concrete block storage little building inside of the Delaware County Jail. Had hollow core roof planks, and this one is almost identical. So this building that you see right here, okay, was called the LOX Repair. It stood for Liquid Oxygen Repair Storage. So it had to be concrete block because it was storing compressed oxygen tanks. So it's a neat little building to estimate. Again, it was part of a bigger aircraft maintenance building, which, if you remember, you did the layout for that in surveying about a month or two ago. So here's the LOX Repair, room 157. It's the plan view. Don't try to scale these because I just took them from a drawing and adjusted them size-wise so they would be easy to read. So I'll give you a little bit of orientation. This is column line 18 right here. And along here is column line 18. So this steel right here is running along column line 18. Column line R is here. And here on the picture is column line R. The LOX Repair had the LOX Repair had two doors. There was a door right here, just to around the corner from this fire extinguisher, and then there was, so that door right there is right up. You can just barely see it, and then it had another, what we would call man door, woman door, whatever, right here. And then an overhead door right here. This overhead door is not this overhead door. This is the one for the big maintenance bay that the LOX Repair room was situated in. So you can't see door 181 and 182. And so here is the door schedule. Door 181 is the overhead door. It's 7 foot 4 inches high by 10 feet wide. It's 181. Doors are always numbered, as are rooms, as are potentially windows as well. Typically doors have their own number. Windows, they will assign a number to all of the windows that are the same. But doors themselves typically have their own specific door number. You may have learned that in ARC 110, residential CAD, doors and window schedules. And then doors 182 and 183, 7 foot 4 inches high by 3 foot 4 inches wide. Okay. Section view taken through here. It's taken through the whole belly of the building, if you will. The entire width of the LOX Repair. You're looking at it this way. So you're looking basically on the right, you're looking down column line R. So when you look at section 3, and again, don't scale it off of this PDF, here's column line R. So this is really out here. This would be the apron slab for door number 182. So we're seeing this section through this wall, which is this, and the section through this wall, which is right here, okay? I'm gonna just take a quick break, double check to make sure I'm recording. Yep. And also to look at my participants, make sure nobody's in the waiting room. So we got 32 out of 42, not bad. And again, I'll get this to YouTube after I'm done here. So what you're going to do, going back to here, is you're going to estimate the block for this building. Okay. And the first thing you're going to do, again, this building now is not just a single wall that you had for the first assignment, which was the north wall of Smith Lab 18, right? We just gave you one wall, we gave you the length, we gave you the height. Now you've got to calculate the total length of wall, okay, of a structure, not just one wall. So you're going to cut the structure into 4 walls. If you go back to here, you're basically going to slice it anywhere you want. And you're going to get this wall length, that wall length, this wall, and this wall. So you got 4 walls, and you've got enough dimensions that you can calculate the total linear wall. So we'll agree on a due date. I'm probably looking at this Monday night at midnight to get all of this done. So as we go through the problem, just think of that and tell me if that's going to work for you. Okay. So figure out that total length of wall. That's the first thing I'm going to look at when I grade this. Okay. So remember, this CMU structure is part of a larger facility. Excuse me. We're going to highlight, if you're able to print this out. If you're not, don't worry about it. But if you were here, and I wish you were, I miss you little, whoop, better not say it, but I do miss teaching you in person. Don't let that get around that I have a soft side, okay, please? So highlight, you're going to highlight each of the different types of CMUs in 3 different colors in the sections shown. Now, when you look at these 2 sections, right, they're pretty much one and the same, if you will. This is just the outside wall. This is the wall that's on the inside of the maintenance repair bay. So this block right here, right, let's say is this block right here, and it literally wraps around the entire 4 walls. So you're only going to take one of these section views and you're going to highlight the bond beams first, right? And you can see that they're calling out the shape of the bond beams, right? And we're using open web bond beams. We're not going to differentiate them for the openings, okay? So we're only dealing with open web bond beams. We'll make them, in other words, they're not going to be any lintel bond beams. What was the difference between an open web bond beam and a lintel or a header bond beam? Anybody? Bueller? Right. The open web bond beam has cores, has hollow cores, and it has these knockouts to let horizontal rebar being placed in them and vertical rebar running through the open cores, the cells, C-E-L-L. The lintel bond beam is solid along the bottom and has that U-shaped trough, channel, if you will, that can be used for an opening. So you're going to find how many courses of bond beams you have. You're going to highlight, and you just highlight just one of the stretchers. You can highlight one of the bond beams, and then highlight the 4-inch solid CMU. Okay, the 4-inch solid CMU. And then you go to the next step and we say, how many courses are there for each type and how high would these courses be? Basically, if you stacked them one on top of the other. So let's say that there was 6 courses of bond beams. They're not. Okay, how many courses of bond beams in this section view? Anybody? Number 37.
Ooh.
Let's try that. How many courses, number 37?
18.
No, bond beams. That's 18 courses total. CR is courses for 12 feet high. But how many courses, how many rows of bond beams in that section view? 27, number 27. Anybody?
Wait, so can you figure it out by just counting the each section up? Or is there like a special way to figure it out?
Well, the bond beam is did you draw a bond beam in ARC 110? Did you draw a concrete block?
Yes.
Yeah.
Did you detail a bond beam?
I don't remember. I don't think so.
Okay, so find that right here it says 8-inch CMU bond beam, 8-inch bond beam, typical TYP. So how many of this type of detail is shown in this section view? 3. So you got 3 courses of bond beams. Now you could say, well, I really got 6. No, you don't, because this bond beam course is the same as this one as it wraps around the building. So you got 1, 2, 3 courses of bond beams. Now if you, each course is how high? How high is a block?
8 inches.
8 inches nominal.
So you got 3 courses, 8 inches a course. How high is your bond beams?
8 inches. Well, 8 times 3, so 24 inches.
Which is how many feet?
2.
2 feet.
There you go. So you got 3 courses of bond beams. 0.67 feet is the same as 8 inches. So if you took those bond beams, took them out of the wall, I gotta let's see here. Hey, Mr. Principato, how long you been waiting? Mr. P. Huh, I thought I let him in. So you got, you took those 3, you peeled them out of the wall and you just stacked them one on top of the other. If you just had those 3 courses, it's 2 feet high. And we're gonna use that height for the area method. So then you're gonna go through and you're gonna find all the number of courses of the 4-inch CMU, solid CMU, and how many courses of stretchers. Okay? And that's what you're going to put there. Now, if you can't make a copy of this, don't worry about it. What you don't have to do is, you don't have to write these questions down. Just write down the answers. Like for this one, total length of wall, give me the total. You don't have to write all this down. That's, you're putting too much time in. Okay? Is everybody okay up until this point?
Quick question.
Yeah.
What's a stretcher?
You got to know that by now. A stretcher is just a regular block. Our regular block's either going to be a corner or a stretcher, but you got to remember that term. The stretcher is the one that has ears on the end and cannot be used as a corner where it's going to be exposed. So that's the stretcher one. It's got those 2 ears coming out with a little channel in it.
Gotcha.
Okay.
Thank you. Sorry.
So again, like I said, read these little notes for yourself. Okay. Now keep asking those questions, even if I bark at you. Don't forget, you got to let the old man bark at you once in a while. So you got some heights, you got a length. Guess what you're going to be able to do with those 2 with those two dimensions? You guessed it, areas. So now you've got the gross area. No doors or entrance is as if the locks repair room is a I just saw an email, so I lost my train of thought. It's the gross area. It's as if that building is built with no doors or doors and entrance, doors and windows, even though we don't have any windows. So the gross area for the 8-inch regulars, again, a regular is a corner or a stretcher. We got the total wall length. This is the data from, actually it was page 3. Okay, we got the total wall length times the height for the stretchers, right? Whatever that height was. We know that the total height is 12 feet 8 inches. It's 12 feet from here to here. Then you got another course. So you got the height of the stretchers as if all the stretchers were just stacked on one top of one another. The bond beams and the 4-inch solid. The wall length is the same for each of those, okay? The wall length is what you found by getting the, what we call the true perimeter. In other words, the perimeter around this little building. So these wall lengths are the same. That's going to give you a square footage. And right. And there's a 4-inch solid CMU. Everybody okay on this one? Any questions?
Nope.
Okay. Before I forget, next week is our last week of masonry. Then we get into one of my favorite subjects. Actually, they're all my favorite, soils. And we'll talk about that Monday night, next Monday and Thursday. Okay, the 2 entrance doors and the overhead or the garage door, if you will, have the same height and position in the cross section. Cross section. Now, excuse me. I took the doors from Smith Hall. Those are the 2 doors that are in the tool lockups in Smith Hall Lab 18. So I said, well, I can use them to symbolize the individual doors to the locks repair building. And then I took that and I stretched it. How do you like that one? So that's now symbolizing an overhead door. And so we said that this door's 3'4" wide. This one says 3 foot. We're going to call it 3'4". I just caught that mistake. Okay. And we're going to change that. Let's do an undo. So we're going to call that 3'4". Damn it, I caught that. Well. So, if we line up those doors end to end, you took this door, and this door.
Wait, I'm sorry. What dimension is 3'4"?
This one says 3'0".
Yep.
We're gonna call it 3'4".
Okay. Thank you.
Hold it. Maybe I can. We're gonna leave it 3'4" for now. Okay. I'm gonna cheat, and I think I will switch it now just so I don't forget it. Amazing. So we took those doors, 3'3" or 3.33, 3.33 wide, 10 feet wide. What's that total length or the total width as if that were one big door? Okay, that's what you're going to put right there. Okay, now, in other words, I did this part first. So we lined up the doors end to end. We called it one long or wide opening. So this number is this number. Okay, but we want to say, where does the height of the doors from here, from the top of the foundation wall, 7'4", where does the top of the door end in this cross section? And you want to use these vertical dimensions. So it's 4 foot from here to here, another 4 foot to here. That's 8 feet total. If I subtract 8 inches, that gives me what? 7'4". So the door, the top of the door is the bottom of this what? Bond beam. So the bond beam, even though it's an open web bond beam, we're going to make it work. And you'll actually get to play around with these bond beams when you come back and we do the lab part. So the top of the door lines up with the bottom of the bond beam. And so the bond beam is the header. You need horizontal rebar and grout to fill in that void so that it can span over the door opening. So within that section, so the door fits from here all the way down, how many courses of bond beams are there from this point all the way down to here?
2.
From this point all the way down to here.
One.
One.
Excuse me, Mr. McKeegan. Devin's in the waiting room. Waiting
Oh,
area.
thank you. I feel like a dentist. Yeah, thanks for catching that. If you see anybody else waiting. Mr. Hunt, you in? Nah, he won't say. So we got 7'4" from here to here. There's only one course of bond beams. One course, 0.67 is the same as what? 8 inches high. So that's 0.67 feet high. We just got one course of bond beams. How many courses are of 8-inch regulars, stretchers? Count them up for me. Number 12.
Yes.
Okay, count up the number of stretchers in there from here down to here. The number of courses of just regular block that's not a bond beam.
So would that be just the individual little blocks?
Yeah, well, give me the number.
Is
How many?
it 12? Or is it more than 12? I can't really
1,
see.
2, 3, 4, 5, 6, 7, 8, 9, 10.
15.
10. I was too old.
Yeah, you probably counted this one, but this one's a bond beam.
Yeah.
And you can't count this one because the door is below that bond beam. So you got one course of bond beams and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got 10 courses of regulars times 0.67 feet, which is 8 inches. So that's 6.7 feet high. You could say that 4 feet is 48 inches less 8 inches is 42 inches divided by let's see, 48 minus 8 is 40 divided by 8, and that's 5. So that's 5 courses of regular here, 5 here, which means 10 courses of regulars. So now we got the height of the block in the opening, the regular block, the bond beam, and we can go to the next one. So all of this data from the previous page, we had the total opening length. In other words, all of those doors, this length right here, times the CMU height, which was this one and this one, and that's going to give us the square footage of 8-inch regulars and 8-inch bond beams for the openings. There's no 4-inch solid block in the openings. By the way, where is the 4-inch solid block and what is its use?
Would it be at the very top, the bottom?
Half block, right?
It's at the very top and used as an outward perimeter for the slab that you're laying through your upper level floor.
Yep, it's basically a cover for the hollow core block. And it's 8 inches high. It's a 4-inch wide block. So it's not a half block, it's a 4-inch block. Because if I talk about an 8-inch block, 10-inch block, 4-inch block, 6-inch block, that's its thickness. So it's still 8 inches high. It's just like a cap, if you will, so that you don't see all these holes in the hollow core. It's the last course around the top of the wall. It actually is the top of the block wall. Everything else is 8 inches, 8 inches wide, except for that one. So that's not in the opening. Okay, so those are all of your square footages. And if you notice, we are differentiating between the different types of the blocks. The regular ones, which is a corner or a stretcher, or the open web bond beam. One thing, when you order 8-inch block, every third block, you order it by the cube. Every third block is a corner block. In other words, you don't buy corners by themselves. Every third block in the cube is a corner, which means 2 out of 3 blocks are the stretchers with the ears on them. Okay, so these opening areas, guess what? Are subtracted from the gross areas. Okay? And once you get the net area, you can multiply it by this, which we learned in a previous PowerPoint. So on a quiz or a test, and Mr. Van Dusen is helping me with that, we'll try to give you at least one test. I'd rather not, but I got to try. 1.125 block for every square foot of wall surface. We would give you that for a quiz. We're not going to make you memorize that. And we went over that actually in lecture in Smith Hall before we all left. So you got the gross area from page 6 for the regulars. I'm sorry, the gross area from page 4 minus the opening area from page 6 for the 8-inch regulars. That's your net square footage. You multiply that number, so that number right there is multiplied by this number, and that's the number of 8-inch block that you're going to order. Now, you always order extra, but we're not going to worry about that for right now. Now, a year from now, as they say, God willing and the creek don't rise, you're going to be taking an estimating course. And Ms. Poole is going to be, she's going to insist that you know how to do this. So you want to keep these PDFs, eventually make a copy for yourself, and you can go back and estimate block at any time. Because all of this is going to go into division 4 of your notebook. If you take the bond beams from page 4, we had the gross area, square footage of wall, surface for the bond beams, as if just the bond beams, okay? We subtracted from that number, we subtracted the opening area, the bond beams that were in the doorways, right? There was only one course in the doorway. That's going to give you a net area for the bond beams. Multiply by 1.125. You now have 8-inch bond beams. The number of 8-inch bond beams that you need to order. Net area for the 4-inch solid. Again, data from pages 4 and 6. The gross area of the solid. Now, you could say that, to be honest with you, the course method would be easier for this one, wouldn't it? It's just one course of 4-inch at the top. And that was another way to do it. I'm going to give you an answer key after this is done. And I'm going to show you both methods. But what we're doing is we're going through the area method for this one. Area method is probably the one that's used the most. There were no 4-inch solids in the opening area. Whoop, I got some, hey, you guys got to pay attention here. There's somebody waiting. So getting back, where the hell am I here? It's getting back to here. That was 0. That was from page 4. There's your net area. Multiplied by 1.125 CMU per square foot. That gives you the number of 4-inch solid that you have to buy. So basically, you're going to fill in these blanks. Oh, no more typing. Only a couple of you did it. I didn't see any collusion, but I did in another course, not your course. And so the rule is you got to do this by hand. You cannot type it. Okay, keeps you honest. Strictly, it's nothing personal. Okay. Is it making a little bit of sense for you?
No.
What
Yeah.
if we're able to like draw on it, like edit the document?
No, you got to do everything by hand. You can't type stuff in. Okay, that's just going to be a rule.
Do we have to write all this, or can we just write like our formulas and then?
What did I tell you? Right, we went over that. I'm still going to grill you guys and gals on listening. I'm still going to grill the sophomores who are emailing me asking me what's due. When I ask them to go read Vanco, I never hear back from them.
Mr. McKeegan, I typed the assignment that was due earlier. That shouldn't affect it, right? Because you didn't tell us.
Have you seen the message that I gave you?
On Vanco?
Yeah.
No, I hadn't. I just handed it in.
Yeah, you're open. Well, if you just handed it in, you were late, so.
No, not just handed in. I meant
Yeah.
I just.
No, I put comments in. I didn't take any points off for the last one.
Okay.
I'm going to accept them on in.
All right.
I've already told you, you don't have to write down everything, okay? And,
Yo, who is this guy?
well, I think we're having another issue here. We did the other day. We got along farther than I thought we would. So we're going to put somebody in the waiting room.
Yeah, the max.
Okay, can you guys still hear me? Can you guys hear me?
Yeah.
Okay. Yeah, that happened in another course. I wasn't going to say anything, so we're going to try to put them in a waiting room. And
Thank you.
well, it's interesting how they got in. This one is it's interesting. What are you going to do? So I'm surprised he waited that long to. And actually, I shouldn't have let him in the first place. I should have recognized that.
Yeah, I'm the only Max here. What the heck?
Right, you're Mr. McNally, right?
Yeah. Yeah.
They had no last name.
Was it you with the gas
Yeah.
issue? Maybe not. Anyway, let's get back to so now we're going to calculate for mortar. Okay. In other words, there's a ratio, and don't worry about where we got this, but it's 0.06 cubic feet of mud per square foot of wall. And we don't care what type of CMU we have because we're going to get mortar in all of the bed joints and the head joints, okay? So now we got the gross area of the 4 wall surfaces. The total wall length is from page 2, right? No, it's from page 3. That total wall length hasn't changed. So let's go 2 and 3. And so we got the total wall length and the total wall height. Now that includes this 4-inch solid CMU. The 4-inch solid CMU, okay? And that gives us our gross area. The opening area, we combine those doors into one opening. That was the data from page 5, and that's our opening area. We subtract the 2, and that's our net area. You multiply it by 0.06 cubic feet of mortar per square foot of wall, and that's going to give you cubic feet of mortar. And how do you get cubic yards?
Divide that by 27.
Thank you. Otherwise, you're gonna hear me cry. I don't know. Can you still see me? No, I don't think you can you? Because you're seeing this thing, right?
We can see you.
Oh, can you? Well, you would have seen the tears. Big old tears coming out of both eyes. So that's about it. Now, what do you think? We have our next Zoom at about 7:45 to 8 p.m. after our surveying on Monday. So my thought is to make this due Monday night at midnight, okay, 11:59 p.m. So you can ask me any questions Monday night, and then you got about 3 hours to fix it. How's that sound?
Sounds good.
Good.
Is that fair? Does that work in with your other schedules?
Answering game plan.
Okay, we're trying to make this so it works for you. Now, again, the Dropbox will close at 11:59. If you want an extension, you have to email me almost immediately after that's closed. Like within, if you miss it, within 5 minutes, I should see an email asking for an extension. Now, if you didn't do that on the first one, there's a couple of you. It's not the end of the world. We're talking for that last one, 20 points. If you give me some documentation as to why you couldn't do it or why I should give you an extension, then I'll consider it. But please understand that even in these trying times, I got to have some proof. We've run into issues in before where, let's face it, we did a little investigation, and anyway, I need proof, okay? Don't send me anything that is personal of nature, but if there's something that you could send me that would document it, so at least I have something, that's what I need. So the 2 or 3 of you, I forget how many there were of you, that need to do that for the past specification homework, please do so. And please understand and don't take it personally. You know, I need something. So figure it out, and I'll work with you. But from here on in, I really have to see something within a couple of minutes of the end of that submission date. I got to see something with a reason as to why you didn't do it. I got 140 of you in 3 classes, and I'm having trouble keeping track of everything. Well, not really, but I am a little bit. Okay?
And make sure when you submit something that it is submitted. Don't just back out.
Yes,
Don't turn into me. Could
absolutely.
have sworn I'd sent that to you 2 days ago, sir.
And you proved that, and that's all I asked. Okay?
Mhm.
But what you got to do is make sure you submit it. If something comes up, and even an hour before it's due, and you know something came up, you got to give me some proof. I'll work with you on the previous one. I'm going to be a little tougher on this one. Okay? And I'm trying to go at a nice, easy pace in terms of being my typical, well, you know what I'm saying. So I'm trying to help.
So if we get the receipt saying that we have a confirmation and submitting something, that's not good enough?
I mean, do you get a receipt from Vanco when you submit something?
Yeah.
I always do at least.
I would make a screenshot of it. And
Okay. I just didn't know if that was going to be like enough for you to say that we didn't turn it in even though we'd get it.
yeah, if you got a screenshot from Vanco,
So what if we have like some personal things going on? What should we do for proof with that?
well, then you can email me individually, and you got to get me something. Okay, you got to get me something. You know, just do it so you know there's no problem with a HIPAA law or something like that. But just give me some form of documentation. You know, the letterhead of a hospital or something like that. I know it's. I'm not trying to be heartless, but I got to have something, and I'll work with you on that. Okay. So give me something. Now, next week we're going to do one more week of masonry, then it's on to soils. This one I think is, you know, hopefully we're walking you through on step by step. Help each other out, if you would please. And let's go to CMU specs. Where'd it go? Oh, here we go. So I put these on there. They look pretty good. You know, it's pretty basic. Specs are, and this is already posted. Specs are pretty boring, but man, are they important. I mean, look at the submittals just for block, general information, product data, shop drawings. Typically that would be rebar drawings, if you will. Samples, list of materials for mock-ups. You had to do an 8x8 size mock-up. Material certificates. That is from the supplier typically. Test reports from a certified lab. I'm working in Albany on Saturday and then in Newburgh for a couple of Saturdays in May, you know, going down there. And these are companies that actually do tests on block, okay? This is a good one, variation from plumb, right? In 20 vertical feet, it can be out of plumb by 3/8 of an inch. The linear building line. If you took a mason line and you pulled it along maybe one course on Evan Tower, within 40 feet, right, in plan view, you can be out 3/4 of an inch. And when we get you back into the lab and we start building these block mock-ups, you'll see just how hard it is to do. This is a biggie. This is a biggie, and this is actually where we have the fun in the lab, trying to get as close to tolerance as possible. Okay. This one talks about the unit masonry. So F prime M is the compressive strength or compressive pressure. And this is both the block and the mortar. Both the brick and the mortar has to be 1300 PSI. The compressive strength of just the block has to be 1900 PSI. So this is the individual block. This is the system of block and mortar, okay? So it's a good little introduction to the specs, and the specs are absolutely critical. So that's that. What else was I going to do? I think, let me turn off, let me pause.